Hello everyone, thanks for joining me in this second section. In the picture, we're going at the components, the main components of an SD-WAN network. In this topology, we can see that we have the controllers on the top and the V edges, C edges. I'm only using C edges, but you can also have C edges. They both do the same. They pass traffic from one side to the other. So we're going to take a look at each controller in this section: the vManage, the vBond, the vSmart. This is an additional server which can be used especially for those who would like to deploy in real network, those who deploy SD-WAN using a smart account. Most of the time in real network you're gonna have to use a smart account to deploy your SD-WAN network. If you also building a topology in DNS3 and you have to use a smart account, most of the time you're going to need to connect to the ZTP or the PNP server. In my case, I'm not using this server because my lab was I signed all the certificates using vManage. So coming back on the components, we have the vManage. We can see that vManage maintains some control connections with all the V edges, and these control connections are management connections. So these connections allow vManage to manage the V edges or the C edges. Basically, it's better for me to use the WAN edges, because if I say WAN edges, this include the C edges and the V edges, but most of the time I'm going to say either C edges or WAN edges. Okay, just wanted to bring that up. Yeah, so the control connections between vManage and the WAN edges allows vManage to manage the WAN edges. We can also see that there is a control connection between vSmart and all the WAN edges, and these control connections are OMP connections. We're going to see what OMP is. It's basically a overlay management protocol, and we're going to see the details. We are not seeing any connection between vBond and the WAN edges, but initially when a device is brought up in the SD-WAN network, it's going to talk to the vBond first. Okay, let's go in the CLI of one of the C edges. I'm going to open the one at the data center, and we're going to see that on all devices in your SD-WAN network, you need to specify the IP address or the DNS name of the vBond. Show running config. So if you go in this device, you can see that we have specified the DNS name of the vBond. Okay, so let me we're gonna take a look at this in details, but this could be an IP address. Okay, but because I'm using two vBonds, let me bring my topology. Because I'm using two vBonds, one vBond at site 1 and another vBond at site 2, I'm using a DNS name. That way traffic can be load balanced or traffic can be directed to the vBond which is available, instead of using an IP address. So let me open both vBonds. That's where you can see that. So this is vBond 1. And in vBond 1, if we do show running config, we can see that the command on the vbond is vbond vbond2.com local vbond local vbond only. So this is the command that you need to apply on the vbond to make it act as a vbond. And you can see this is something I think I need to adjust. This is vbond 1. Okay, let me see the vbond 2. Okay, then this is vbond 2. vbond 1 and vbond 2, but both are using vbond 2 as a DNS name. So that's why all the WAN edges and the controllers are pointing to vbond 2. Basically, if let me show what I did. So that vbond 2 is translated to both IPs of the vbonds. If you're going to deploy your topology in DNS with only one vbond, then you're gonna have to use the IP address. I mean, you can use the IP address of that vbond. You should use the IP address here for the vbond. Okay, but seeing that I'm using two vbonds, I have pointed this host name to the IP addresses of both vbonds. So that's way, if when a WAN edge will come up, it's gonna talk to that host name, and that host name has two IP addresses. So basically, it can go to vbond 1 or vbond 2, depending on which vbond is available. So that's why I'm using an host name instead of an IP address. So I was trying to go to explain why we don't see a control connection between vbond and the WAN edges. When a WAN edge comes up for the first time, the entities it's going to talk to is the vbond. Okay, so there's going to be a control connection with the vbond the first time, and once the vbond is going to authenticate the device and connect that device to vmanage and vsmart, that control connection will be dropped. We can we can see that. I'm going to disconnect the cable going to DC1 VH, okay, kind of to break the connection. So I just deleted the connection. If we go back to vmanage, now that cable is connected, but let's go to the CLI and see what's going to happen. So if we do show control connections, we can see that this device is talking to vbond at this time, right? It is talking to vbond, and that's started about 9 seconds ago. Okay, and at the same time it started talking with vsmart and with vmanage, almost with all controllers, but it is the vbond which is going to introduce this device to the other controllers. So if we go back, we're gonna recall the same commands, adding the tab. You can see the connections with the vbond is no longer part. Is not. I mean, we do not have any connection with the vbond. So that's once the vbond introduces the device to the vmanage and the vsmart, the control connection is terminated, and that's as long as there is going to be stability, there is not going to be any control connection between the WAN edge and the vBond. So coming back to our topology, and if we can check here, I think we should see this device available on vManage. Okay, it's not reacting, but okay, yeah, it's back. So let's go back to our topology. We just say that there is a management connection between the vManage and the WAN edges, and a control connection. Transport. The transport. Look, this is not right. Okay, sorry. This should be. This is not overlay. This is underlay. There are two types of transport in the underlay. So this is the underlay transport, okay, and this is the tunnel overlay. The connections between the V edges through the transport, okay, through the transport, those connections are part of the underlay transport. Let's say you are connecting V edges, a V edge which is in Los Angeles with a V edge which is in Paris. The connection on the one side, on the WAN interface, going to through the internet, okay, let's say you're using the internet, going to the V edge which is in Paris, that connection is the transport, is the underlay transport. And then once this connection is created and you add up some configs, you can build the overlay tunnels which will be created from the service side interface, so the interface that will be facing the LAN, the local area network, or the service side. So that interface, I'm using G002. There's going to be a tunnel between this interface and the interface on the other side, the service interface on the other side, and this is what is called the overlay tunnel. Okay, and this tunnel is going to be used to transport the data traffic between both sides. So that's why we're seeing the overlay tunnel between the sides. There are a couple of components that we see the system IP and the site ID. We're going to take a look at those. So for now, let's move on to the next slide. Cisco SD-WAN operates on a control-based architecture. There are three types of controllers: the vManage, vBond, and SD. Or the controllers can be on premises, so in the cloud. The choice to install, to deploy your controllers on premises or in the cloud just depends on several factors. And we don't need to discuss about that here. The controllers can be deployed in a form of cluster. So you're going to have like a set of controllers on the west coast and a set of controllers on the east coast. That's just for redundancy, and that's what we tried to we have simulated in our lab. We have two set of controllers. We have the the vBond, vSmart, and vManage in Dallas, and we have the vManage, vSmart, and vBond in Sao Paulo. That's why if these controllers are, there could be a power outage at the site, and these controllers are no longer available, then the controllers in Sao Paulo can take over and help you keep running your network. So that's about building clusters, and we're going to take a look at the details when we move along. The vManage. Let's give a couple of details about the vManage. It provides a management front-end GUI, the graphical user interface, and that's what we have been looking at. We have the GUI of the vManage right here. It is also used for certificates management. If we go to vManage, this one, we can go to vShell, and we can see that typing LSL, we signed the certificates of all our equipment. So this is a certificate. So if I do cat just to see that certificate for DC1, we can see that we have the beginning of the certificate and the end of the certificate. So all the certificates were signed by vManage in our network in this lab. Device registration. So if we go to the vManage GUI, if we go to devices, we can add devices. We can add a controller, a vBond or a vSmart. With vEdges, it's going to be the upload of the one edge list. So that's about device registration. We have the config deployment and management. We went over this in the previous section, and we're going to look at this in more details in the next section. We have the network monitoring. We went over this, how you can monitor your network. All the WAN devices maintain a management connection with vManage, and we just went over that. Now let's look at vSmart. It's the routing core. It's an important piece of equipment in the SD-WAN, in the Cisco SD-WAN network. It maintains global overlay routing table. So basically the routing table, it is maintained by vSmart. It's learn and advertise routes to and from one edge devices via OMP, donc overlay management protocol. So if we go back to our topology, we can give an example. Let's this route, this subnet at DC Paris is going to be injected in the, it's going to be learned via the vEdge at DC1 and DC2. And it's going to be that's why all policies are going to be created from vSmart. Not all, but the centralized policies. So we're going to look at that as well. And the next maintains OMP control connections to each one edge. We just saw that. OMP is a Viptela proprietary protocol. So this is not a Cisco protocol, but I mean, it belongs to Cisco now, but it was created by Viptela. Viptela is similar to IBGP with a route reflector. vSmart is a route reflector. Basically, what a route reflector does, it reflects the route received. Let's say you have your route reflector here, and you have routers, okay? If the route reflector receives a route coming from say router 1, it's going to send that route to the other devices, but it depends on the policies. So that's basically what a route reflector does. OMP, yeah, we just say that vSmart is a central connection of the vEdge. All WAN edge devices maintain a control peering connection with vSmart, not with each other. So there are no control connections between the vEdges, between the WAN edges, only with vSmart and vManage. All routing policy, route manipulation, and filtering are performed on the vSmart. Routes come back from a WAN edge device, and vSmart perform any configured policy and advertises the route back. Routes coming, okay, to be more accurate, routes coming from a WAN edge device and are sent to vSmart, and vSmart will perform any configured policy. So just to be more accurate, a route can come from, if a route is coming from this vEdge, it is going to be sent to vSmart. vSmart is going to apply any policies, okay? Let's say you don't want this prefix to be advertised to DC11, then to site 11, sorry. Then vSmart is going to apply that policy. It's going to send that route to 22, 33, and 44, but it's not going to send to 11 because the policy says don't send that route to 11. vSmart is also where we can manipulate routes attribute and perform filtering. So let me show a couple of route attributes that we have on the OMP routes. If I go to DC1, if we check the show IP route first, we can see that we have these routes. We have connected the routes. We have a static route, and we also have this connected route. And we also have this OMP routes. Okay, these are the OMP routes. Let's take a look at one of these OMP routes. Show IP routes. Let's say we're going to check this one, and let's add detail. Okay, these are the attributes we have. The protocol is OMP, the distance is 250, the metric 0, the uptime of this route, the TLOC, okay, 11111, the TLOC caller is biz internet, the encapsulation is IPsec, the next op label is 1, and the status is FS. These are a couple of attributes that you can manipulate to decide I mean to see how you want to advertise your routes. Let me see. Show IP routes, OMP, detail. Yeah, you can see all the OMP routes that you have. Basically the same. So let's go back. So that's basically about vSmart. 3 other lines. vSmart brings the data IPsec connection up by distributing the VPN credentials between the vEdges. So this is a very I mean, this is really important, and it makes your life easier, because if you have to build in this topology, we have kind of 8 WAN edges. They should build VPN tunnels, VPN connections between them. So basically that means DC1 should build a connection, a tunnel with this, with site 2, with site 33, with site 44, with this device and this device. And these tunnels will be built, created based on the transport. Seeing that we only have one transport, we only have like 1, 2, 3, 4, 6, 7. Okay, let's go back and see exactly how many tunnels we have. We can go to vManage. I'm gonna delete this. We can go to vManage. Let's go to network. Let's choose one device. And if you go to tunnel, we can see the tunnels that we have between DC1 and the other devices, and we can count 1, 2, 3, 4, 5, 6. We have 6 tunnels. Okay. Yeah, we have 6 tunnels. Okay. But these tunnels are only between the two. Are only between the biz internet and the biz internet transport on the other side. By the time we're going to deploy our MPLS transport, we're going to see that the number of tunnels will grow because we're going to have another type of transport, and other tunnels will be built over that transport. So tunnels are built based on the transport that are used on the WAN edge, between a WAN edge and the remote WAN edge. And the fact that vSmart takes care of the VPN credentials, this makes your life easier. You're not going to make any configuration on WAN edges about IPsec. vSmart handles the ongoing VPN key management. The authentication between WAN edges to bring IPsec tunnels is automatically taken care of, so you don't have to do anything. vBond on both devices into the SD-WAN system. It authenticates all the devices. It helps the WAN edges to find the vSmart and vManage servers so they can build control and management connections to them. So when I already say that, just to repeat it, when a device for the first time get into the is brought up into the SD-WAN fabric, it's going to connect to vBond, and vBond is going to introduce that device to vSmart and vManage, and then that device is going to build the control and the management connections to vSmart and vManage. vBond is the first entity any device will talk to. It needs to have a public reachable IP. Sorry, WAN edges, vEdge, cCloud, WAN edge, iOS XE, they do what they do. They route traffic. Okay, the traffic coming from sites is routed by the vEdges. They also perform data plane functions. Okay, quality of service, ACL, and zone-based firewall. Each one has a management connection to vManage and a control OMP connection to vSmart for routing purposes, and data connection to other WAN edges. I'm not going over the ZTP and PNP, but basically the ZTP zero-touch provisioning and PNP plug and play are both servers that are used if you going to use a smart account to deploy your SD-WAN network. Let's give a quick overview of the transport. The transport network, also called underlay network, okay, is used to transport data packets between the WAN edges. The most popular transport are MPLS, Internet, VPLS, 3G, 4G, wireless. At least one transport type is required. More than one transport provide redundancy. That's what we're going to do. We're going to have the MPLS transport and the Internet transport. The transport network only provides connectivity between the WAN edge devices. It should know about the WAN IP address of each remote WAN edge. Enterprise routes are exchanged between WAN edges over the overlaid tunnels. So this simply means this. If we go back to our topology, the transport side, okay, this is underlay, I'm gonna remove this. The transport side allow this vEdge to connect with this vEdge, to connect between them, okay, to provide IP connectivity. But routes coming from each local area network, because we have the WAN side, okay, and the LAN side, okay. The LAN side is where you have, like, if this is a building, you have all the PCs in the building, all the equipment that we need to connect with other devices. So this equipment, these PCs on the LAN side, on the LAN side or the service side, are going to run, are going to connect to send traffic over the tunnels. Okay, and the tunnels are built over are the overlay transport, the overlay tunnels. So the traffic is going to over the tunnels to the other side. So that's basically about the transport between sites. Okay, so this is the transport network. About the overlay network. The overlay network runs on top of the transport network to securely transport data traffic. Data traffic is transported via IPsec tunnels that are built between WAN edges. By default, the WAN edges build a full mesh IPsec tunnels. We're going to see how to change if you want a hub and spoke topology or any other type of topologies. We're going to see a couple of topologies like the hub and spoke, and I think with two others. A couple of terms. System IP, unique device identifier similar to a router ID. Apart from the IP addresses, each device in the WAN edge network will have a system IP. Site ID, this is kind of an identifier of all devices that are located at the same location. So for devices that are at the data center, we have two devices. They both should have the same system ID. So these devices should have the same system ID. This should have the same system ID, and these three also. These three also. They should have the system ID, which I call the site ID. So that's about the system IP. And the domain ID, a group of vSmart or vEdges that share the same routing info. One domain ID is required per overlay. The bring up process, I'm not going over this again because we already saw. We already went over an overview of the steps, and if you would like to go over, I said there's a playlist that you can use if you want to build your topology, a self-hosted topology. So that's gonna be all for this section. I'm gonna see you in the next section. We will start talking about the templates, how you can build your templates. I already have templates created, but we're going to see. Let me go here, sorry. Configuration, templates. We have the feature templates. I created many templates that allow you to bring up your network to build, to allow connectivity between the sites, and we're going to review all these templates, how you can create the templates, and once we're done, we're gonna move to bringing up the elements of network, like bringing up NTP, all the other technologies like syslog and other stuff. Yeah, so that's gonna be all for this section. I'm gonna see you in the next section. If you liked this video, please like it. If you have any comments, any observation, don't hesitate. And if you are not part of the channel, please subscribe, and I will see you next time. Thank you.